Hey, what's up guys? Here's WEIQI Zheng with my video presentation. 8th March 2014 was a huge day for the world. Malaysia Airlines Flight 370, known as MH370, was a scheduled international passenger flight that disappeared on that day, and yet the aircraft has not been recovered. The cause of the disappearance still remains mystery. Several pieces of marine debris were found on the coast of Africa and on Indian Ocean islands off the coast of Africa. It was the first discovered on 29th July 2015 and have been confirmed as pieces of Flight 370. Today, I'm going to talk about how might have ocean circulation on Indian Ocean spread debris from wreckage of Flight MH370. First, I'm going to introduce the main current that occurs on Indian Ocean. And then I will do some analysis about how current movements push the debris across the Indian Ocean. There are 6 main currents on Indian Oceans. First is northeast monsoon current. Second is India counter current. Third is southwest monsoon current. Fourth is Indian equatorial current. Fifth is Mozambique current. Sixth is west wind drift. Northeast monsoon is a warm current. The winds blow from land to the ocean during winter season in the northern hemisphere, and thus westward blowing northeast monsoon currents are produced spring Edmund and Somali. This current flows to the south of 5° north latitude. Besides, some of independent currents originate in the Bay of Bengal and the Arabian Sea and flow in a southwesterly direction. India counter current is a warm current. It is originated during winter season in northern hemisphere. This current flows in easterly direction between 2° to 8° south latitudes from Zanzibar to Sumatra. Southwest monsoon current is also a warm current. There is a complete reversal in the direction of monsoon winds during summer season. In other words, northeasterly direction of winter monsoon winds becomes southwesterly during summer season in the northern hemisphere. This reversal of direction of monsoon winds also reverses the direction of ocean currents of Indian Ocean during summer season. Northeast monsoon ocean currents disappear and the southwest monsoon ocean currents are developed. The general direction of monsoon currents is from southwest to northeast, but several minor branches emerge from the main branch and move in the Bay of Bengal and the Arabian Sea. The India counter current developed during winter season disappears due to this current. Right under southwest monsoon current is the Indian equatorial current, which is also a warm current. The currents of southern Indian Ocean are least affected by seasonal change in the direction of monsoon winds. The Indian equatorial current flows from east to west between 10° south and 15° south latitudes, from Australian coast to African coast. After being obstructed by Madagascar, this current is divided into many branches. One major branch flows southward in the name of Algohus current, while the other branch is directed towards the north. Now let's look at the left side of the map. One branch of southern India equatorial current moves southward through Mozambique Channel, known as Mozambique Current. This current joins the Algohus Current near 30° south latitude and then moves up to the southern tip of Africa and is ultimately diverted eastward. Now everyone moves your eyes to a cold current on the bottom of the map. Like Pacific and Atlantic Oceans is a west-flowing current, known as west wind drift, is also generated in the Indian Ocean. This current is produced due to eastward blowing westerlies along 40° north latitude, known as rolling forties. This current bifurcates in two branches near 110° east longitude. One branch turns northward and flows as West Australia Cold Current along the western coast of Australia, and near the Tropic of Capricorn turns towards west and northwest, and ultimately merges with the South Equatorial Current near 100° east longitude. The second branch of the west wind drift turns southward. Now, I assume everyone has a certain understanding of the Indian Ocean current movement. Let's go back to our flight again. The first debris was found on 29 July 2015 near Reunion Island. Reunion Island is practically on the other side of Indian Basin from where the investigators think the missing airplane may have gone down. So how did this chunk of airplane get all the way over there? She'll answer, it was pushed by current, wind, and the waves. Let's take a look at graph of current movement. The most obvious feature in the graph above are all the arrows pointing westward just south of the equator around 10° south to 15° south. It is called the South Equatorial Current. Debris from the aircraft got caught up in this flowing water and were likely pushed across the Indian Ocean smack dab onto Reunion Island. But it is a little more unclear in this image how the debris got north from the search area into the South Equatorial Current. The culprit, the West Australian Current that flows northward along Western Australia. You can't see it too clear here because there's a lot of small scale it is that math with the averages. But if you look at even longer term averages, it is there. The debris probably just took a very squiggly northward path until it reached the South Equatorial Current. This is a historical map of Indian Ocean Gyre. Both South Equatorial Current and the West Australian Current are part of the larger Indian Ocean Gyre, a giant rotating vortex of water in the southern Indian Ocean. Some of the debris, if they manage to floating that long, may even end up back on the Australian coast because of the gyre. We should also note that the debris was found about 4,400 kilometers away from where the plane might have gone down, and it took about 505 days since the plane disappeared and the debris been found. Scientists made a rough calculation. The drift speed of the debris needs to be about 0.1 meter per second or 5 miles a day for debris to get to Reunion Island from the search area. That's pretty close to the current speed in the plot above, so it's totally plausible that this debris is from the crash. The search for answers regarding the plane's disappearance has been a long and difficult one. More debris from the wreck could end up on Reunion Island or at least near it in the future, if it has not already. Even though we found pieces of the plane, we can't pinpoint exactly where the plane went down, but there might be clues in the debris itself to at least indicate what caused the plane to veer so very far off course and disappear. My hope is, if investigators can find some more debris, they can figure out what happened to MH370 in the first place. and finally give the families of those on board the tragic flight can find some answers and peace. That's pretty much for my presentations, and thank you all for watching.